I'm going to show you how to test a 2SC945 on a Heathkit IT121. So we're going to go to the data sheet and we're going to take a look at what we need to know from the data sheet. Here's the data sheet for a 2SC945. We can see that the pinout is ECB, so we can hook up our test leads to the device. If we look down below, we will note that the beta group of P, there is a P on the case of the device. We're looking at a beta anywhere from 200 to 400. After looking at the data sheet, we've got a device that is in the P beta group, which should be around 200 to 400. And we also know that we've got a device that's got a pinout of ECB. We can therefore hook up our transistor to ECB, red being E, white being B, black being C. Take note that I've made this set of test leads using Pomona mini grabbers. Pomona mini grabbers are pretty much the best mini grabbers on the market. They fit into very tight little spots. They are very, very well designed. It is very unlikely that you're going to short out a very tightly spaced pinout device with Pomona mini grabbers. First step in testing the transistor is we want to set the beta switch to beta equals infinity. We want to have our range switch on 10 milliamps, which is the best range for small signal devices. We want to be in the transistor mode, transistor versus FET, so we want to be in the transistor mode, and we turn the unit on. Now we want to adjust the set beta equals infinity knob so that the needle lines up with the infinity mark. So you can watch the needle move a little bit. We set the needle to infinity. The next step is we want to press the beta cal switch, and we want to adjust our beta cal knob so that the needle lands on cal times 10. That's the best setting for small signal transistors. So this is basically your multiplier, and I'll go into that in just a moment, but we set the needle into that block. And now we test the beta of the transistor by pressing the beta switch. And we've landed at beta equals 30 on the scale, but here we've got our multiplier, cal times 10. 10 times 30 is equal to 300, which is well within the range of our predicted 200 to 400 beta. So now you've got an idea how to use this tester for transistors. It's very similar to test FETs. One thing about using an analog meter for testing transistors is you've got your quantitative data, your 30 times 10 equals 300. But with experience, you'll find that you can get a little bit of like qualitative data by the way the meter reacts, by how quickly it reacts. Does it move around a little bit once it's landed on a spot? All these meter movements will give you more of an idea of the condition of the transistor, and experience will show that.